Welcome to the video module on the basis of the basics of map and compass. A map is any picture or other representation of important features in the same relative positions as in nature at the time that the data for the map were collected. Maps can show us where things are in relation to each other. They can help us find where we are and decide where we want to go. They can help us decide how to go from one place to another and what to expect along the way. In short, maps are an aid to navigation. The compass is a circular instrument that helps us find direction relative to a known identifiable feature, and we'll discuss that issue in detail in a different video presentation. The compass then is also an aid to navigation. All right, now we need to look into some facts about navigation. Pretend that you are standing in a spot, perhaps in the middle of a field, trying to decide which way to go. You slowly turn around in place, looking all the while, until you realize that you are back facing the same direction where you started. You have turned in a complete circle and have looked every which way. All right, bear with me now. This circle stuff quickly becomes important. Centuries ago, some mathematical genius decided to break a circle up into 360 equal units of direction from the center of the circle. That is the spot where you stood when you turned completely around. And he called these units of direction degrees, and you see the degree mark there in parentheses. This concept is important for both map and compass. Notice two important things. Number one, by convention, degrees are numbered clockwise, starting with 0 at the top, all the way around to 360 back at the top. Thus, top is both 0 degrees and 360 degrees. This is important to remember. Number two, there are always 360 degrees of direction in a circle, no matter how big or how small the circle is, because we are talking about direction from the center of the circle, not distance around the outside of the circle. This concept is important later when we talk about the compass, because compasses come in different sizes. There may be small compasses, there may be big compasses, but regardless of how big or small, regardless of size, each compass describes 360 degrees of direction. Now let's move on to something more fun, geography. A basic understanding of world geography is necessary for you to get the most out of your map and compass skills. We have day and night because the Earth rotates around an imaginary line called the axis of rotation. One end of that imaginary line is, by convention, there's nothing magic about it, by convention called the geographic North Pole. And the other end of that imaginary line, again, by convention, is called the geographic South Pole. Now, if all of this looks sort of kind of like a circle, you're right. You can think of the Earth as a ball, a three-dimensional circle. Okay, the next point is very dry, but it's necessary, so bear with me and follow along. If, wherever you are, you face toward the geographic North Pole, you are facing geographic north. Makes sense. If you face toward the geographic South Pole, you are facing geographic south. Now, if you face the geographic North Pole and do a right face, that is, turn 90 degrees clockwise, by convention, you are now facing geographic east. And if you now face geographic north and do 3 right faces, so that you turn 270 degrees clockwise, by convention, you are now facing geographic west. And this emphasis on geographic will become clear later when we talk about the compass. By convention, then, north, south, east, and west are the 4 cardinal directions for navigation. Okay, now we have to pull all the preceding information together so we can talk about Earth navigation. Now at some point, some smart aleck is going to point out that the Earth is not a perfect circle. It's not a perfect ball. It's close enough. And for our purposes, we're going to consider the Earth to be a circle, a three-dimensional circle. Now we need to talk about the concepts of longitude and latitude so that we can locate specific points on our three-dimensional circle. Longitude. If we draw a series of straight lines connecting the north and south geographic poles, we could draw 360 of them, one for each degree, at equal intervals around the Earth, as we would around a circle. These lines are called meridians of longitude. Here's a schematic of the Earth showing a series of lines connecting the North Pole and the South Pole. These are meridians of longitude. Now, we need a reference point to identify or number the meridians of longitude, and by convention again, the meridian that passes north and south through Greenwich, England, is designated as 0 degrees longitude and is called the prime meridian. Here you see the prime meridian in red and labeled 0 degrees, passing north and south through Greenwich, England, Western Europe, and Western Africa. The meridian exactly opposite the prime meridian on the other side of the Earth is called the anti-meridian. Longitude is measured 180 degrees both east and west of the prime meridian all the way around to the anti-meridian for a total of 360 degrees. The circle model holds. Here we can see meridians of longitude drawn every 10 degrees and numbered independently from the prime meridian east and west around toward the anti-meridian on the other side of the Earth. Now let's look at latitude. If we draw a line all the way around the Earth, connecting all points equally distant between the North Pole and the South Pole, and perpendicular to the meridians of longitude, we will have drawn the equator. And here's our schematic showing the equator in red circling the Earth in northern South America and Central Africa. We can now draw a series of equally distant parallel circles around the Earth, north and south from the equator, to the north and south poles. These parallels of latitude are numbered from the equator at 0 degrees, independently north and south to the north and south poles at 90 degrees respectively. Here we can see our parallels of latitude drawn every 10 degrees and numbered independently north and south from the equator at 0 degrees all the way to each pole at 90 degrees. Let's confirm that the circle model holds with latitude. If we start at the equator and travel directly to the North Pole, that covers 90 degrees of direction. From the North Pole down the other side of the Earth to the equator opposite where we started is another 90 degrees, 180 degrees total. From the equator position on the other side of the Earth to the South Pole is another 90 degrees, and from the South Pole back to the equator position where we started is yet another 90 degrees for a full circle of 360 degrees. The circle model holds. We can use latitude and longitude together to designate exact positions on a map. Where am I? Where do I want to go? And they can be used with a compass to determine directions to get there. Aha! Navigation. So the example shown in the picture here shows that Washington, D.C. is located at 39 degrees north latitude by 77 degrees west longitude, more commonly indicated as 39 degrees north by 77 degrees west. As an aside, when coordinates like this are given, latitude is always given first, followed by longitude. Now, picky point. Latitudes are sometimes noted as positive numbers north of the equator and negative numbers south of the equator. Similarly, longitudes are sometimes noted as positive numbers east of the prime meridian and negative numbers west of the prime meridian. Thus, the location of Washington, D.C. could be represented as 39 degrees by minus 77 degrees. I tell you this only because at some point you're going to see notations like this. Another picky point, but important because you will see it during the video on maps, and sooner or later we'll see it on other topographic maps. Just like a circle can be divided into 360 degrees, each degree can be further subdivided into minutes of direction. There are 60 minutes in a degree. And each minute can be further subdivided into seconds of direction. There are 60 seconds in a minute. This is important when you're doing surveying, but in scouting, we're not going to have to worry about minutes and seconds, but you need to know because you will see them on topographic maps. Meridians of longitude and parallels of latitude can represent each of these subdivisions. So, for instance, a very finely measured meridian of longitude might be 135 degrees, 27 minutes, 16 seconds west. This could also be represented as a decimal of degrees, 135.454444 degrees west, or, because it's west longitude, minus 135.454444 degrees. Sooner or later, you are going to see these types of designations. We now know enough about the basis of navigation to move on to the basics of two important tools of navigation, the compass and the map. It's time to move on. We hope you've enjoyed this video and found it informative, and will move on and watch the other videos in this series. With practice, you too can become a world navigator.